Welcome to Ask Al, presented by Quad Plus. Here's today's question. How can I avoid fees from my utility related to power factor, flicker, and peak demand? So I've certainly been on the receiving end of some electrical bills where either power factor has been an issue causing increased costs, or we've had a period where we've used very little electricity, and yet I still receive this large demand charge on my bill. I've also received some letters just regarding power quality, and certainly as it was related to flicker. I've had certain, on the user side, experience with these. Today I have Joe Kowalkowski with us from Quad Plus to talk a bit about his experiences. Joe, what exactly is flicker? What causes it, and how is it measured?
Flicker is the perceptibility of the human eye to detect variations in light changes. And GE developed this standard and created a relationship between voltage change and light changing in an incandescent bulb. And this is still used today. It's a very arbitrary measurement, but standards like IEEE 1453 have kind of quantified what the acceptable levels of flicker are. Today they're often measured in two terms that's called PST and PLT, short-term and long-term flicker. Short-term is generally 10-minute statistical average of voltage variations, where long-term would be a 2-hour measurement. The causes of flicker are literally voltage changes. So if we have a very high load demand, say there's a very large motor starting across the line, we will dip voltage enough where it becomes perceptible to the human eye. So we put these meters on and we measure this, or we can model this in a simulation and predict what our PST and PLT values would be. Through that, then we would be able to design a system that would withstand the starting currents or magnitudes that we're dealing with.
Okay, so if I'm a plant operator and I've either identified that I have a problem or I'm looking to make upgrades in my plant that may create an issue, I'm not sure, how do I go about resolving and mitigating?
So there's two things there that you identified. I'd call it a proactive engineering solution and a reactive engineering solution. If we were developing a greenfield or brownfield plant, our proactive engineering solution would be to look at the topology of the drive system powering whatever the application is, and use a technology that would minimize flicker without adding excessive infrastructure for the end user or plant operators to maintain. Something like this would be the use of a variable frequency drive. If we had a 5,000 horsepower induced draft fan, there are many advantages to using a drive on that, one of them being reducing flicker, because now we can tweak the delta voltage over delta time relationship by adjusting parameters in the drive and ramping the motor up to speed instead of doing an across the line start, which is very hard on a line, especially with a squirrel cage induction or a long rotor induction motor. The reactive solution is, say for example, we do have a long rotor motor, a 5,000 horsepower long rotor motor that we start across the line. Your solution there would be either a capacitor bank, or we could look at a static VAR compensator. Both of those would be sized to correct the power factor that we needed. This solution usually starts with actual measurements. We want to know exactly what the power factor is at the point of common coupling, or PCC. And from there, then we can design how much reactive power we need to supply to correct that the flicker issue.
All right, let's switch gears a bit to power factor. What is power factor? You know, why do you get scenarios where it's less than 1? And more importantly, why do I have to pay extra if my power factor is less than 1?
So power factor is your relationship between real power and apparent power. Real power is what it takes to do the work. Say again, this 5,000 horsepower machine, how much current is it going to consume to do that work? Apparent power is what the utility is going to have to supply to do that. So it's a phase relationship between the parent and real power that creates reactive power. Reactive power is what we need to correct for. What we're doing is applying either capacitive or inductive loads to correct that power factor and make sure that we're providing unity or 0.95 to the utility.
Okay, so what are the typical approaches that you would take to improving your power factor? And, do you get to a point of diminishing returns, for example, where really for the cost, the payback isn't there?
Yeah, that's a good question. That's usually when you engage a engineering firm to review this, that is certainly a calculation to look at, and generally 0.95, you're not going to get much better than that. Even 0.9, you're almost better to pay the utility penalty than take on the expensive added equipment on your plant. However, when we look at, again, say this 5,000 horsepower wound rotor system, that might have a power factor of 0.72, 0.75, and there is a lot of money that you could be saving on the utility costs. And so we would look at designing either, again, a static VAR compensator or a capacitor bank, a staged capacitor bank, to bring that power factor as close to 0.95 as we could. And then there's legitimate return on investment with that equipment.
Okay, the other item I see a lot on electrical bills are peak demand charges. Do you have any examples of where you've gone into a site and taken actions to reduce their bills?
Sure. There's, as you mentioned, there's two components to a utility bill, generally usage and demand. Usage would be measured in kilowatt hours. Demand would be measured in kilowatts. Demand at most utilities in the United States is measured on a 15-minute average, and what this means is they will charge you, $4 a kilowatt for your highest 15-minute average in any one billing cycle. And this changes from utility to utility, so it's important to understand how your utility charges you for demand. Co-op utilities, they often just charge a straight usage rate at a higher cent per kilowatt. But with demand, what we're looking at is your highest 15-minute average usage during your billing cycle. What this means is if you have a very variable load, say for instance, it's a printing press or a car shredder, for example, where you're constantly drawing more or less current, you might in one period draw 2,000 kilowatts and the next you might draw 4,000 kilowatts. There's technology that we can use to help regulate that, where maybe you really only ever need 2,200 kilowatts, and we can average that in where you can manage your utility bill and reduce your kilowatts down to 2,200 kilowatts. And it has a huge impact on what your demand charges are. So variable demand systems like this, there's some ways to increase your value of the system. The ways that we do this are through software. So we would have to put some software into a PLC or some device that would be able to first calculate demand and then compare that to what the user expects his demand to be, and correct some variable in the system, whether it's a feed rate into a machine or the actual current limit of the motor that we're trying to control. And we have clients that run large motors like this that we save around $85,000 a year in utility bills by helping them manage their demand.
So then what's the typical ROI, the return on investment on those types of programs?
In that scenario, the customer that we helped with $85,000 a year, it was an ROI of about 1 to 2 months.
Great. Thank you very much, Joe. So Quad Plus offers a number of different services to help you mitigate issues with your power supply and also reduce your costs. If you have any questions, just give us a call or send us an email. And as always, if you have a topic that you'd like us to address in a future video, just send me an email at al@quadplus.com. Remember, work safe, lock out, tag out. Thanks for watching.